Hello, hello, hello. Can you all hear me in the back? All good? Okay, give me a thumbs up if you can hear me. Okay, cool. All right. So, welcome to 61B CSM Review Midterm 1. First of all, we posted the slides already on the Piazza, both for 61B on the class itself. Okay, not yet. She's working on posting it on 61B, but we posted it on CSM61B, so you can, if you're not on that Piazza, join it, and we posted the slides in case you would like to follow along on your own laptops. Apart from that, today we will be going over, we'll start off with static and dynamic types. So I'm going to cover this in 11 sections. So hopefully, this will be everything you need to know for your midterm. Hopefully. We will not, so instead of going over questions, I decided to just give you all the things you need to know in example forms. So after this, any questions you see, you should be able to do them. If you can't, you can email me personally and I will reply to you. After that, we'll be going over abstract classes, interfaces. So I'll go over the theory, at which point we'll probably take a little break, or maybe breaks in between, depends. And then I'll hand over to Karuna, who will be going over midterm questions from abstract classes, interfaces. And then we have some more slides and exceptions, after which we'll go over some more midterm problems. So this will be the overall structure. Before we begin, does anyone have any questions? Okay, in general, if you have a question, raise your hand. If I happen to not see you, just scream question, and I will see you. All right? Cool. Let's get started then. So, static and dynamic types. Before I actually start, I want to take a survey. How do you guys feel about static and dynamic types? Thumbs up, somewhere in the middle, or thumbs down? Okay, so right now it's like somewhere in the middle and thumbs downs. By the end of this, I need thumbs up from everybody, otherwise you're not leaving. So, get ready. All right. So let's get started with static and dynamic types. Here's how it works. First of all, we're going to go over initialization without any form of casting. So let's just talk about what happens when you initialize a variable. What happens when you do this? When you do dog d equal to new dog, the keyword on the left, dog, is the static type, right? And the keyword on the left is the static type. The keyword on the right is the dynamic type. So in this case, both the static and dynamic type of this variable d is dog, the class dog. What does this mean exactly though? So here's how I like to teach it. This analogy really helped me, and a lot of students have told me it helps them. So here's how I like to teach it. When you write dog d on the left hand side, the compiler creates for you a box and labels it dog. Okay? Inside this box, you're allowed to put anything that is a dog, essentially. So when you go to runtime, well, what the compiler does is it creates a dog for you. So new dog means literally create a dog, and then put it in this box. Is this okay? Sure, right? It's a box labeled dog, and then you can sure put a dog inside, not a problem. So the compiler says this is fine, and this is during runtime also this is fine. All you did was you made a box for a dog and then you put a dog in it. It runs just fine. So now let's take this second example where let's say that the bulldog class extends the class dog, and you do dog d equal to new bulldog. What are we going to do? Well, again, we're going to create a box, label it dog, inside which we'll try to put a bulldog. Is this okay? This is also okay because we label the box dog, and of course we can put a bulldog inside something we label dog. That is not a problem because a bulldog is a dog, right? Is that clear? Good. Sorry about that. Okay, the compiler checks that what you're putting in the box is allowed to go in the box, and formally this is the compiler checks whether the dynamic type is the same class as or the subclass of the static type. All right, so this is the formal thing that the compiler checks. That's all the compiler cares about. Okay? And let's look at another example. Say that the bulldog class again extends the class dog. This time we have bulldog d equal to new dog. The compiler is going to make a box, label it bulldog, and this time the compiler is going to try to do this. Is this okay? No. What's happening here is we labeled it bulldog, so we can't put any generic dog in the box. We have to put something that's either a bulldog or a hungry bulldog or a thirsty bulldog or some form of bulldog. So the compiler is not gonna let you put a dog inside a box you labeled bulldog. It's simply not okay. So formally, the compiler checks whether the dynamic type is the same class as or the subclass of the static type. Once again, this is gonna be a compiler error. So far, are there any questions? Okay, so if there are no questions about this, this was, oh, we have one more, not step one. Step one's not done yet. Okay, so let's say that we have cat and dog both extending animal, and cat and dog otherwise have no relationship to each other. So I want to know which one of these are okay and which one is not. The first one, dog D equal to new animal. Is it okay? Is it not okay? Just scream it out. Not okay. What about animal A equal to new dog? All right. Dog F equal to new cat? No. Cat C equal to new animal? No. All right. So I think at this point you guys understand this step one to understanding static and dynamic type. This is step one. All right. What are your questions at this point? Anything? Yes, question in the back.
Is there any point in doing this? Because why can't you just set bulldog D to bulldog?
All right, that's a great question. So the question, because I'm also trying to record this, the question is, what is the point of doing this? Why not just always set bulldog D equal to new bulldog? So the simple answer is that when you're writing code, right? Let's say you're writing some code, and you know that you want to write a function that takes in any form of dog, right? You want to write a function that can be called on any dog. For example, all dogs can bark. We know this, right? So you want to use that function again and again and again. So what you want to do is you want to get an object, and it can be any type of dog. It can be a dog, a bulldog, doesn't really matter. Some third party will send you this object, right? And you want to be able to accept it, no matter what it is. That's why when you write your program, maybe you want to write the type to be dog so that it can accept any of the types. So some examples of this that you have seen or will see are, for instance, the word list, right? List, you can set it to be an array list, a linked list, an int list, many kind of lists. So that's why on the left-hand side, you want to write the word list so that later, let's say 3 days later, you realize, oh shit, my code is actually pretty horrible if I use like a linked list. Maybe I should be using an array list, right? So you can just change it to be an array list without it creating any issues later. Does that make sense? So that's why we wanna do this kind of separation. Any other questions? That's a good question. All right. So then let's move on to step two. Step two is initialization and casting. So let's understand what it means to cast and why we would want to cast and what's going on in general. Okay. So let's first set this up. I'm going to have dog D1 equal to new bulldog, and I'm going to have bulldog D2 equal to new bulldog. So I've set them up in the form I've been showing you, the boxes and the labels, and I'll keep them there that way. So that's the setup. Now, remember the big idea? The big idea here is that after we make these boxes, so after we've written that line that I wrote, after these two lines, the compiler has no idea about what's inside the boxes. This is super important. The compiler only checks what you're putting in the box the first time you put it in the box. After that, the compiler has wrapped it up. The compiler cannot see inside the box. The compiler does not see the dynamic type. The compiler only sees the static type. I'm saying this again and again, so it sticks. The compiler only sees the static type. In fact, this line is so important that I'm going to keep it there for the next like 50 slides. Okay? Super important. Okay. Now I'm going to do this. Bulldog D3. So I'm creating a new bulldog variable, right, that has static type bulldog. I set it equal to D2. Is this okay? Just somebody scream it out to me. What do you think? Yeah. This is okay because I take a box, and I know that earlier I would have, like, as the compiler, I know that earlier I would have only allowed a bulldog or something like a bulldog to go in there. So I can just empty its contents into another box labeled bulldog, right? So D3 is the new box that I created. And I can take everything of D2 and put it in without it being a problem. So this is allowed. Sure, the compiler makes a box labeled bulldog for D3 and puts the contents of D2 inside it. It's not a problem. What about this? Is this a problem? Okay, so this is a problem. Why is this a problem? Yes. Perfect. Because of this line. The compiler only sees the static type. The compiler does not know that inside the box is actually a bulldog. So this is a problem. The compiler is compiler makes a new box, D4, labels it bulldog, and then tries to put in D1 inside it. But listen, D1 was labeled dog. I don't know what's inside it. I can't take the contents and just transfer them. Does that make sense? Now this is where, so okay, let's see. This is not allowed. But we argue D1 is actually a bulldog, right? We put it there, so we know it's a bulldog. We're telling the compiler to believe us, but it doesn't believe you. It says, no, the static type, I only see the static types, I have no idea what's inside there, right? So formally, the static types of D4 and D1 are not the same. But the dynamic type of D1 can actually fit inside the static type of D4. So what can we do here? This is where casting comes into play. Casting in this extended analogy is a way to tell the compiler to believe you. When you cast things, the compiler says, okay, I'll believe you. So let's see how this works. What if I do this? This is, like I said, this is casting. What I'm telling the compiler is that, hey, listen, inside D1, there is a bulldog. I know it's labeled dog, but there is a bulldog. And this is the syntax for doing such a thing, right? You just write a bracket of the class that you know is actually inside the box, and you make the compiler believe you. Now, will this work? Okay, so the compiler will actually believe us, and like I said, this is the user telling the compiler. The compiler believes the user because it is possible that there is a bulldog in there. Okay, so there's something here that I have written in bold. Well, there's three things, but let's look at the second bullet point. Second bullet point is the compiler believes the user because it is possible that there is a bulldog in there. Okay, this is super important. Keep this in your mind because I'll be coming back to this in about 60 seconds. Because it is possible that there is a bulldog in there. It's actually possible, right? If it's a box labeled dog, and we try to lie to the compiler, telling the compiler, hey, trust me, there's a cat in there, that's a straight up lie. There could not have been a cat inside a box that's labeled dog. The compiler would never have allowed that in the past, right? So this is a reasonable, this is something reasonable to tell the compiler. Trust me that inside this, if you see a box, it's labeled dog, and you're telling the compiler, trust me, there's a bulldog in there, that's reasonable. So the compiler will believe you. Okay? Yes, question.
So for your example where you say there's a cat that you're trying to tell it's a dog, would you get a compile error if you were to do that?
Yeah, so that would be a compiler error, and I have that on my slide, so don't worry about it. It's coming in, like I said, 60 seconds. The next 3-4 slides come to it, right? But this will compile. So as far as this one is concerned, yes, question.
So here like this, the compiler check D1's static type?
Does the compiler check D1 static type? No. So all that happens is you tell the compiler, hey, listen, D1 is okay. So let me rephrase that. D1's static type is actually like dog, right? We made it to be dog initially. It's labeled dog. So the compiler makes sure that bulldog, the thing you are saying it actually is actually a subclass of the label. Does that make sense? Question. No, sorry, bulldog is a subclass of dog, right? So when you're casting, if this thing is a subclass of the static type of this thing, it's okay. Okay, can you see my mouse? If bulldog is a subclass of the static type of D1, which is dog, then it's okay. All right? Questions? Yes. Yep, it's not checking what the contents are. It can never know the contents. If you told it that this was actually a hungry bulldog, is that possible, first of all? Yes, it's reasonable, right? It could be. It's not actually, we know it, but it could have been. The compiler will still believe you. Make sense? If you told it that this was a Chihuahua, the compiler will still believe you. Okay? Awesome. So this compiles. And now there are two kinds of lies. So far we talked about one lie a little bit. So we'll talk about two kinds of lies now. And this is where this thing called compiler error. So far we've seen one compiler error. What was the compiler error that we saw on the slide so far? Someone remind me. We saw one compiler error. What was it? Anyone remembers? Yes.
Where the dynamic type was like a superclass of the static type.
Right, so where the dynamic type was a superclass of the static type. That was, let's see if I can find it. Well, these ones, right? These are all compiler errors. So we saw these, and we have not seen any other kind of errors yet. Okay? Yes. Sure.
So when you cast D1 as a bulldog, so the compiler checks that bulldog is a subclass of whatever the static type of D1 is, but does it also check to make sure that like the static type of D4 is the same, is compatible with this new cast?
Absolutely. So the question here was, yes, sure, the compiler checks that this casting is allowed. The fact that D1 static type is dog. The compiler makes sure that bulldog is indeed a subclass. That's fine. The compiler is still going to make sure that this entire statement can still be true, right? What we are saying now is, trust me that on the right-hand side, there is a bulldog, right? If on the left-hand side you had hungry bulldog, this would still not work because a hungry bulldog still cannot fit inside something that's a bulldog. Does that answer the question? All right. Yes. That is a great question. So this box analogy only goes so far, right? The compiler isn't actually making any boxes. This is just to understand. So in this case, if it helps you, you can think about it as the compiler made a new box. But a box is essentially, in my analogy, a variable. The compiler is not making a new variable when it's casting here. So there's no new variable created. It's basically temporarily, for this line only, relabeling this box. Does that make sense? It takes this box, it says, oh, let me not read this label and let me read this new label instead. Does that make sense? All right. More questions? Okay. Cool. With that then, two kinds of lies. Let's dive straight into it. Lie 1. This is a lie that is going to be caught at compile time. We talked about this a little bit, right? D1 is a box labeled dog. In this line, I am telling the compiler, hey, it's actually a cat. This is not a reasonable lie. The compiler would have never allowed this in the past. Does that make sense? Any questions about this? So what's going to happen in this case is, there's going to be a compiler error. It's going to read like that. It's going to say error, incompatible types. Dog cannot be converted to cat. It's like, that is literally impossible. Are you kidding me? Is that cool? Okay. So this is the compiler saying, there is no way that D1 can hold a cat. I would never have allowed this to be true during initialization. Right? When you made the variable D1, I would have never allowed you to put a cat in there. So this is impossible. Questions about this? Okay. This is the second kind of lie. We haven't talked about this one yet. So let's try this. Dog, real dog is new dog. So I've made a real dog. Both its dynamic and static type are dog. And that's why I'm calling it real dog, just so that it's clear. Okay? Now I try to do this. Bulldog fail. Something should tell you that this line fails because the variable is fail. So bulldog fail is, I'm casting real dog to be a bulldog. So here's the first question. Does this compile? All right, I heard a no, and I heard some yeses. So someone in the yes crowd give me an answer, and someone in the no crowd give me an answer. All right, yes.
I think yes, because the compiler sees that the static type of real dog is dog, and it is possible that the dynamic type could be bulldog. So it sees no problem with compiling it.
All right, so I heard some disagreement. What is, someone from the no crowd give me an answer? Yes. Okay, so the arguments were that, okay, from the yes crowd, we had an answer that this would actually compile because, of course, it is possible that the real dog variable actually inside there is a bulldog. And from the no crowd, I heard that it's also possible that it's other things, so the compiler says nope. Okay, here's the answer. It does compile. It compiles just fine. And the reason is exactly what was your name? Jeff. What Jeff said. So the idea is that as long as it is possible that it is a bulldog inside real dog, this will compile. It'll compile just fine. Is that clear? All right. Compiler says, sure. What happens during runtime? Okay, now, so far, I've had this line up here that says, the compiler only sees the static type of objects. Now let me tell you a new fact. I hope I have it here. I do, all right. The runtime only sees the, okay, the word only is a lie. I get rid of it later. I forgot to get rid of it here. Let me actually do that real quick, because it's not only. The runtime sees everything. Okay. Okay. Give it a sec. All right. So the runtime sees the dynamic types of objects. Okay. Is this gonna be a problem at runtime? I might be tricking you with the word fail. So is this gonna be a problem? Okay. It is gonna be a problem. Runtime says you lied. Runtime sees everything. Okay. It's like when the Amazon person writes on a package that inside here is a bulldog and you find a generic dog, like when you open it up, you're like, hey, you lied to me. So this is a lie. If you lie, you will be caught. So here's the general idea. If you cast, you better not be lying. If you're lying, it'll either be caught during compile time, if it's an obvious lie. If it's a reasonable lie, it'll still be caught during runtime. Does that make sense? So in this case, what actually happened is going to give you this exception that we call class cast exception. It says, hey, dog cannot be cast to a bulldog. I see that the thing actually inside there was a dog. You told me it was a bulldog, so I let you compile, but you lied. Does that make sense? Questions about this? Yes. It's a great question. All the possible ones, I don't even know. Java has a lot. But the common ones, probably. So class cast exception is a very common one. And it might be useful to know it. Compiler does not compiler just is usually just compiler error. Like if you, or it says like, this cannot happen, this cannot happen. So it's not really, there's no name to it usually. But for runtime, there's like class cast exception. There's array index out of bounds exception. There's null pointer exception. I can't remember any more myself. So I think if you know these three at least, there might be more, but at least know these three for sure. Array index out of bounds exception is obvious. Null pointer exception, obvious-ish, and class cast exception. This one is the one that people usually don't know. Okay, so this is just line number 2. Yes?
So for example, if like real dog's dynamic type is, say, small bulldog, would there still be a class exception?
It's a great question. What if real dog's dynamic type is small bulldog? Is this a problem? No, because a small bulldog is a bulldog, right? So if you're saying that, hey, look, there's actually a small bulldog inside there, and you relabel that box. So casting is like relabeling this box, right? Like I said, it's like temporarily relabeling this box, only for this line. When executing this line, I'll relabel this. If I relabel it to be bulldog, and later I inside find a small bulldog, that's not a problem. I didn't make any lies. I was being completely honest, right? That makes sense? All right, so it really helps me to think about this as lying. Like if you lie, you will be caught sometime. So that's why I like to teach it this way. Hopefully it's helping. All right, now are there any other questions about this? Okay, cool. So far we've done 3 steps. Initialization with casting, and then we've seen 2 lies when casting can be a problem. Okay, so this is a running summary of what's going on. All right, let's move on to method calls. So first we'll see how to compile them, then we'll see how to run them, and then we'll see what else happens. Okay? All right. Compilation requirement. So I put that thing in a red box just so that it's there in the rest of your life. Just remember it forever. The label, which is the static class, so the label class, the static class, must be able to execute the method. What do I mean by this? Examples coming up, but just know this. The label class or the static class must be able to execute the method, otherwise it's going to be a compiler error. Why is this? Because the compiler can only see the static type of the objects. Okay? All right. Question? Cool. So I'm making some, can everyone read this in the back? I'll read it out. Say that the dog class, it has a bark method, and say that the bulldog inherits the bark method, so it also has the bark method, and it has its own crawl method. So let's just say bulldogs can crawl. I couldn't find any other thing that bulldog can do. So I saw a YouTube video, someone's crawling. I was like, okay, cool, you can crawl. So let's say bulldogs can bark and they can crawl, but dogs can only bark. Okay? This is the example. What happens if I do something like d1.bark? So d1 is still the same thing. Its static type is dog. Inside there is a bulldog. I'm doing d1.bark. What's going to happen? Is this going to compile? So the only question we're asking right now is it going to compile? Sure, right? Dogs can bark. Sure, why not? What about d1.crawl? No. Why is this? Yes. Perfect. So the dog class does not have a crawl method. The compiler only sees the static types of objects. The compiler does not know that inside there's a bulldog that can actually crawl. Is that clear? All right. I put that there again. Yes.
Was the compile time error before you called crawl, or when you first initialized it? Or like, was it when you called crawl, or was it when you first just initialized the object?
Well, of course, this initialization would work, right? We saw earlier that inside a box labeled dog, you can put a bulldog. So the initialization itself is not the problem, right? When you call the crawl method, though, the compiler says, hey, wait, this dog doesn't have a crawl method. You can't call this method, so it fails to compile at that line.
Okay.
Right? Is that clear?
So it doesn't compile all the way.
It fails as soon as it sees this line, it fails.
Okay.
Right? Yes.
Like if both dog and bulldog have the bark method, let's say dog takes like dog's bark method takes in an int
Mm-hmm.
and bulldog's bark method takes in a double,
Mm-hmm.
then d1 dot bark with
Okay, so let me actually stop you right here. This is something that I'm going to be covering soon. So don't worry, I haven't missed any cases, trust me. That will be coming up, but just not yet. So I'm building this step by step. Let's go step by step. Not yet. Okay, right now I haven't dealt with any sort of parameters. That'll be coming in soon. So right now it's just vanilla method calls with no parameters. Okay? It'll be coming soon though. So hold tight. All right? Also, let me get back to your question. So you said that, does it not compile all the way? So that's not the way to think about this. When you compile Java, for instance, it's possible that it gives you like 10 errors, right? It is at the same time. So it does compile all the way, except this is one of the lines that errors. Does that make sense? So in your error output, it'll show you this as being one of those lines. Cool. So it's not like it sees this line and then it just like doesn't print anything else, right? Okay. Any other questions? Yes. What would this error be called? Let's see if I have it. No, I don't. So I don't know, but it'll be a compiler error. I don't know what it would print out. It would be something along the lines of, actually wait, it says symbol not found, something like that. Yeah, I've done this enough times yesterday to remember it. It says symbol not found. Basically what that means is it tried to look for the crawl symbol inside the dog class and it didn't find it. Right? So it says symbol not found, something along those lines. But I encourage you to try it out. All right, question. Can I, sorry? Can I lie to the compiler? Or you mean can I make the compiler believe me? So yes, and I think that's the next thing. Yeah, so I don't have that here, but yes, indeed. So what you can do is you can cast. Why can you cast? Because actually in there is a bulldog, right? So yes, you can cast. You can. Let me actually show you how it'll happen. Let's do it live. All right, over here, you do. Well, see, this is what I have to fix. Okay. All right, let me get rid of this cross, and let me delete this. Okay. So you can do bulldog d1. Mind the syntax, so you have to have a lot of parentheses. This Now, will compile. Is that clear? Yes. What if there are attributes? Okay, so attributes in Java behave differently. They behave differently than methods, and actually I don't have them on my slides here. That's because Professor Hug does not teach them, and neither does Professor Hilfinger, I believe. I mean, I went through his slides and I couldn't find anything. So, and that is like really convoluted, and fields behave like in a really, really weird manner. So fields, like for instance, like not functions, but just like variables, I don't have them here, and I don't think you have to know them. That's why I don't have them here, because this is a midterm review session. Although I'd be willing to talk about it after. Cool? Yes. Yeah. So where do you want to have it? Right here? Like this? I don't know. I think this would just like be like a syntax error because it will be like confused. But I'm not sure what the ordering is. So try it out. I don't have some code to run it right now. Yes. If D1, okay, what if D1 doesn't actually have a bulldog? Who's going to tell me what it's going to be? What's it going to be? I'm hearing it, not loud enough. It's going to be a runtime error because this is lie number 2. It's a reasonable lie. It could have been a bulldog, but it's not. Right? So during runtime, it's caught. Class cast exception. All right? Cool. More questions? Okay, then let me revert this slide back to what it was. Okay, awesome. Moving on. What methods to run? So far we've talked about compiling of methods. Now let's talk about running them. And I'm still going to go with the no arguments case. Like I said, there are 11 steps. We're on step 5. So don't worry. We'll get through all of it. It's just coming step by step. Okay? All right. So let me give you some starter code. I've put these two things in red. The compiler only sees the static type. Runtime sees the dynamic type. This is a box. Real dog. It's labeled dog. It has a dog. That's why it's called real dog. And then I have D1. It's labeled a dog. It's actually a bulldog. Okay? Let me show you the rest of the code. Let me zoom out a little bit. Okay. So now the dog class has a bark method, like earlier. It prints out I am a dog. The bulldog class has a bark method. It prints out I am a bulldog. And the bulldog class also has a crawl method. It prints out bulldogs can crawl. One thing that's missing here is extends dog. I just realized this. So the bulldog class can extend, is extending dogs, okay? So I wrote this out, but I forgot to put extends dog. Okay? All right. Oh, oops. Okay, never mind. The answer's here, guys. Real dog.bark. Will this compile? Sure, right? The dog has a bark method. The class dog has a bark method. So this compiles just fine. Now the question is, what does it run? There are 2 bark methods, right? Which one does it run? The dog one. And this one is like a pretty simple case. The static type is dog. The dynamic type is dog. So why the heck is it going to run the bulldogs method? Like, it makes no sense, right? So it runs the dogs method and prints out I'm a dog. Okay? Cool. Next up, real dog.crawl. What happens? I heard it, but louder. It's going to be a compiler error. Good. So that is because the compiler only sees the static types. All right. This is the example that I actually just showed, so I didn't need to do that, but I guess I did it anyway. Bulldog real dog.crawl. Runtime error. Good. I think I messed it up. Oh, yep. Line number 2. Class cast exception. Cool, right? This is what I showed you. Questions about this one? Okay, it's a reasonable lie, but it's a lie nonetheless. What about d1.crawl? Compiler error. Checks the static class. No idea what to do. Bulldog d1.crawl. First, does it compile? Sure, compiles just fine. What about runtime? It runs. Very good. Prints out bulldog can crawl. All right. d1.bark. Does it compile? Good. Does it run? What does it print? Okay, someone scream it out. I'm a bulldog. Does anyone think it prints I'm a dog? Yes. Okay, so it's a great question, and let me also hear what you have to say. Okay, go for it.
I think it's because it'll compile as a dog, but then in the runtime it'll see that bulldog also has bark, and so then that'll override. Or, I don't know.
Okay, so great question and great answer. That segues into dynamic method selection. So I'm going to answer this question, this exact d1.bark question, in this section. You see how I segue in the middle of a question? All right. What's going to happen here is actually something called dynamic method selection. I haven't talked about it so far, so it's a new term. But it's pretty simple, so let's dive straight into it. What's going to happen is, of course, it's going to compile, sure. The static class has a bark method, so it'll compile just fine. Okay, now I'm going to say this out, and I'm going to say it out maybe twice, and I'm going to say it out so that you guys hear me really properly. The compiler has now decided that no matter what, it will run a function that looks exactly like void bark. This is important. It's going to be, and I know you guys are like, what the heck? Why is the no matter what so important? It's going to be important when I come to functions with arguments. But for now, remember this statement, at least until your midterm, super important. No matter what, the compiler has decided that it will run a function that looks exactly like void bark with no function, with no parameters. Cool? Okay. What happens during runtime? During runtime, I told you that the runtime sees the dynamic type. During runtime, your computer, it realizes that D1 is actually a bulldog. So first thing it does, it looks in the bulldog class for a function that looks exactly like void bark. So the compiler decides that I'm going to run something that looks like void bark, no matter what. And then during runtime, we look for a function that looks exactly like that. But we start looking in the dynamic type first, because it's actually a bulldog, right? So let's look there first. Hopefully we find it. If we don't, we'll check the superclasses. We'll keep going up one by one, looking at each superclass. So if we don't find in bulldog, we'll check dog, then we'll check animal, then we'll check like mammals, then we'll check like earthlings, and then we'll keep going. Okay? But first we'll check bulldog. We find it in bulldog. We find this guy. All right? So this is what we print. This idea of checking the dynamic type, the dynamic class for that exact method which the compiler selected for us is called dynamic method selection. Are there questions about this? Yes. Bulldog, okay, so the question here was, what if bulldog overrides the parent's method? Bulldog is overriding the parent's method. So in this case, okay, let me define the word override. Override is simply if the superclass has a function of exactly the same type, which I mean void bark with no parameters, and the subclass has an exact same function, then it's called overriding. And overriding is exactly overriding is exactly what's actually happening here. Okay, so if the bulldog method takes in an argument, so let's say that the bulldog method didn't actually it didn't have a bark method with no arguments, it only had one that did have arguments. What is going to happen? What do you guys think? Yes? Okay, so let me cross question. You said it won't work. What do you mean by that? Would it Would it run at all or would it fail? Okay, so there's one thought here that it would fail. Yes?
I think it would run because it can't find void bark with no arguments in the child class. It goes into a super class. It checks there.
Good. So, and this is a good discussion. So the idea here is that if, let me say this out loud again so everyone hears it. If this bark method in the bulldog class actually took in a parameter, right? What's going to happen is we are going to look for a function that looks exactly like void bark. We are going to check bulldog first. We are not going to find it in bulldog. So we are going to go to its superclass. We're going to go look in dog. We find it in dog, so we run that one. Does that make sense? Yes.
What if like they took a different type of like they took in one argument, but it was like a string for one and a int for one? Would they see it as different?
Yes. So the question was, what if the dog class took an argument of type string and this class took an argument of type int? They would see it as different. These would be different arguments. So over here I say, in fact I use this term that I should probably not have used. It says looks exactly, right? See this phrase, looks exactly? By looks exactly, I mean it has the same name and the same type of parameters in the same order. So a function that takes in a string and an int in that order is different from a function that takes in an int and a string. So it's the name, the parameters, the types of the parameters, and the ordering of those types of the parameters. Make sense? Yes. Okay, let me just say it, and the return type. But the return type is a little bit more flimsy. So let me write something out and ask you a question. Let's make a new slide here. And let me ask you a question, all right? Let's say that we had a function that looked like void bark, and it did something. And then we had another one that looked like int bark. And it didn't take in anything, but it did something. Okay, so we have two functions. Now, let's say these are in the dog class or whatever, right? And now I call d1 dot bark. Which one should I call? I don't know. Should it be the one that returns an int? Should it be the one that returns nothing? I don't know. Right? This is going to be a compiler error. So the compiler itself will be like, hey, look, you can't have two functions that have the same name, that take the same arguments, and return different things. Because then when you use these functions, I don't know which one to call. Yes?
All in the same class or is it
Sure, so it's all in the same class, but even if it was in different classes, what I'm trying to, okay, let's say that the first method was in the dog class, okay, so I'm saying it out, hear me out, I'm not writing it. If the first method was in the dog class, and the second method was in the bulldog class, okay, and now I call, let's say, with a bulldog instance, I call the second method, right, or I call like dot bark. What's going to happen? It's still not going to know which one I meant to call, because it has no idea whether I meant to call the one that gives me an integer or whether I meant to call the one that gives me back nothing. I don't know. Does that make sense? All right. So to get back, let me answer your question first, just to get back to your question, which was, and the return type, right? So I said three things matter. I said the name of the function, the types of the parameters, and the ordering of the type of those parameters matters. Then you asked me, what about the return type? Well, if the return type is different and everything else is the same, those functions won't be allowed to compile. So it doesn't matter. Like, does that make sense? Absolutely. This would still be a problem because, okay, different packages, I don't know, but different classes in the same file for sure. Essentially, if you are overriding, right? So what is overriding? Who wants to define it for me once again? Overriding? Somebody, come on. My hand's gonna get tired. Okay.
So in a subclass, you basically put a method that has the exact same signature as the method in the subclass.
Okay, so overriding is, let me redefine it, which is in the subclass, you put a method with the exact same signature as the superclass, right? Overriding, and I'm saying this, overriding cannot be done if everything else is the same and the return type is different. If the name of the function, the type of the parameters, and the ordering of the parameters is the same, and you change the return type, this will not be allowed. This is not a valid kind of overriding. It will not be allowed by the compiler. Is that clear? Okay, going back then. Okay, so this was everything on dynamic method selection actually, and this might be surprising. Yeah, let me ask you a question, yes?
Will it change the method of bar to be static?
Static methods, okay, so static methods at the end. We'll talk about those right at the end. Okay, so stay put. It's a great question. All right, how am I doing on time? Pretty good actually, not too bad. Okay, cool. Actually, I don't know, we'll have to see. Okay, let's move on to step 7. So let's do methods, this time with arguments. So this is the big reveal. Also, I just want to say that you guys might realize that dynamic method selection actually had only 3 slides on it, and maybe it's some of you when I took the class it was like, oh, dynamic, I don't know what the heck that is, right? It's this super convoluted dynamic method selection, this obscure topic. It's actually not much. It fits in 3 slides, so it's clearly not much. It's just make sure you understand this idea. It's just this idea. If you get this, that's dynamic method selection for you. Okay, cool. Methods and arguments. So far, we haven't had any function arguments. So let's learn how to deal with arguments. This time, I'm going to stop with the whole box analogy because I'm pretty sure it's settled in and you guys are tired of my ugly boxes. Instead, I'm going to have a nice, uglier table. So I have 3 variables, real dog, dog and dog. I have real bulldog, bulldog and bulldog. And I have cross dog, dog and bulldog. Why do I not have, so I have 2 things that I'm changing. Why do I not have something that's bulldog and dog? Because, yes? Right, exactly. So if I actually had bulldog dog, that'd be a compiler error. It's not possible, right? That's why it's stupid to have it here. Okay, so I have these 3 variables, and I'm going to be using these in the next, 40 slides-ish, so remember them. They're given easy names, real dog, real bulldog, and cross dog. And now let's look at this. Oh, whoops. The compiler only looks in the static class. We've seen this like 300 times now. For arguments, the compiler tries to find the most specific method that takes in the static type of the argument. Now, I know this is a mouthful. I'll show you examples. But let me read it out anyway, formally. For arguments, the compiler tries to find the most specific method that takes in the static type of the argument. Let's see what I mean by this. So let's say, again, this time I have 3 methods. I have a class dog. It has a method bark that takes in a dog. I have a bulldog that extends dog. It has a method bark that takes in a dog also. So as you can see, these 2 methods are being overridden. Their name is the same. The type of their parameters is the same. Okay? And I have in the bulldog class, I also have this other method that's bark bulldog d. This is called overloading. Within the same class, when you have multiple methods that have the same name, same return type, but different parameters, that is called overloading. Okay? Okay. Cool. Let's see what's going to happen now. What happens if I call real dog dot bark real dog? Become the compiler for me and tell me what's going to happen. What is the compiler going to do? First thing the compiler is going to do is look at the static class of real dog. It's dog. Does the dog class have a bark method that can take in something of type dog? Sure, it has this method, right? So the compiler chooses bark dog to be the signature of the method it will run no matter what. Okay? During runtime, we look at real dog's dynamic type. We see that it is dog. So we look in the dog class for the method type that the compiler selected. We see this method, we run it. Is that cool? All right, this was straightforward. What about real dog dot bark real bulldog? So what's going to happen when we compile? Yes.
Shouldn't it fail because it's going to see that the parameter takes in a dog, but it's putting in the static type, which is a bulldog?
Okay, so I have a candidate for it fails because it takes in Here, this is real bulldog, whose static type is bulldog. So there is no method in the dog class that has static type bulldog. Any other thoughts? Yes?
The static type of real bulldog is bulldog, but that is a subclass of bulldog.
Okay, so that is actually what happens. Let me repeat that. So, real dog, we are looking for a bark method that can take in this guy. It should be able to take it in. Okay? Let me ask you, does this method's argument, right, is of type dog. Can a dog box hold a real bulldog? Sure, right? It's not as good as we would have liked. We would have liked for it to be able to take a real bulldog itself. We don't have that option, right? We have the next best thing. Make sense? Does that make sense to everybody? So let me read this again. The most specific method that it can find, right? This was the most specific method that it could find, this one. So it finds it and it compiles. Except, here's the thing. The compiler chooses bark dog, so bark and something that takes in a dog, to be the signature of the method that it will run, no matter what. Okay? What's going to happen during runtime? I'm going to realize, hey, real dog is actually a dog. Did I mess this up? Yes, I did, a little bit. Give me a sec. This should have been, sorry, this should have been cross dog. And then it's still correct, so let me fix that. Okay, so let's go back and make sure that everything still holds, right? So if this is cross dog, this still compiles because it looks in cross dog static class, which is dog. And so far, our discussion is correct, right? Any questions about my little change? So I changed it from being real dog calling that method to cross dog calling that method, okay? Now, dynamic method selection is going to take place. We're going to realize, hey, cross dog was actually a bulldog. So what does the runtime do? Runtime looks inside the bulldog class for a method that looks exactly like bark dog. Okay? It finds this one and it runs this one. Not this one. This one would have been better for us, sure. But the compiler selects the signature for us. This is probably the most difficult thing to settle in with Java, in my opinion. So, are there questions about this? The compiler selects the signature. The compiler selected, this is the signature that I will run. Then during runtime, we realize that crossdog was actually a bulldog. So we look in bulldog class and we look for something of this signature. We find it, we run it. Questions? Yes. Where it check real bulldog's type, static type or dynamic type? Okay, so here's the thing. It never checks real bulldog's dynamic type. So here's a fun fact. The parameters that you pass in, the arguments that you pass in, their dynamic type simply does not matter. It doesn't matter at all, ever. Dynamic method selection takes place on the caller instance, only on this guy. The argument, it doesn't matter. Yes. Absolutely. So once it realizes that real bulldog static type is actually bulldog, it looks in the dog class for a method that can take a bulldog. It finds the one in red. Then you see this exact same method here. That's the one it runs because crossdog was actually a bulldog. Questions about this? Yes. How can we change it so that it actually prints I took a bulldog? The only way to do that, actually, yeah, the only way to do that is by casting crossdog to be a bulldog. If you cast it to be a bulldog, then it'll check in the bulldog class. Correct? Okay, so I have 3 questions. Let me go at the back. Yes?
So you
8 would print I'm a dog. So that's the reason that I messed up here. Yeah. So if instead of cross dog, this was, I had not changed it to be cross dog and it was actually real dog, then it would just print out the method in red. It would print out I'm a dog. Yes, question. Okay. So the code would look like this. I would put parentheses around here, and then here I would do bulldog, and then here I would put another set of parentheses. Actually, wait, hold up. I think I messed it up. It's gonna look like that, and one more here, and then one less here. So let me make this bigger so you can see. Oh, all right, there we go. That's what it looked like. If I do this, it's gonna print out I took a bulldog. Why? Because the compiler is now gonna check the bulldog class for the most specific method that it can find. It finds this one. It says I will run something that looks like this. Then it checks this class for something that looks like this. It finds this one. It's happy. It prints it. Questions? Yes. Oh, sure thing. On to what exactly? Okay. Sorry about that. Let me wait. Hold on. Okay. That's what it looks like. It's a janky line of code. Oh, whoa. Keeps moving. Questions? Anything else about this? Okay.
Step by step,
Absolutely. Okay. Let me change this thing back to what it was. Ta-da-da-da. Huh. Okay. Give me a sec. Okay. Step 1. I will check cross dog's static type. It is dog. Correct? All right. Inside the dog class, I will look for a bark method that is able to take in real bulldog. Real bulldog's static type is bulldog. Okay? So I will try to look for something that has the form bark bulldog inside the dog class. I don't find it. I don't see anything that looks like bark bulldog. I find something that looks like bark dog though. So I ask myself, does that work? Sure, it works. So this line compiles. Except the compiler also selects the signature for us. So now the compiler has made its mind that it will run a method that looks like bark dog. Okay? Let me finish the story and then I'll take questions. So it will run a method that looks like bark dog. It compiles, that's done, and the red method signature is selected for us forever. Okay? Now in runtime, we will look at this guy. Okay? And okay, so this should also be crossdog. That's why maybe there's some confusion because I changed this midway. My bad. So now runtime realizes, hey, crossdog's dynamic type, right? So the callee instance, the caller instance, its dynamic type is actually bulldog. So the method that I selected that I'm going to run, let me look for that in the bulldog class. Exact method signature. I find it. It's here in blue. So that is the one I print. Does that make sense? This is weird, but this is how it is. Question? Sorry, if I got rid of what? Great question. If I got rid of the blue method, it would print the red method. Because, again, that no matter what in red is super important. The compiler selects the signature for you. And it will run that signature no matter what. No matter what. Question?
What if you pass the type of the parameter? So if you said bulldog is real bulldog within those parentheses?
Well, okay, so if you change it to bulldog, real bulldog, all you're doing is you're saying, hey, its static type is real bulldog, but its static type is already real bulldog, right? All you're saying is that real bulldog static type, okay, let's look at this. By casting, all you would be doing to real bulldog is you'd be saying, hey, its static type is bulldog, but it's already bulldog.
What if you, okay, this is
Mm-hmm.
But like, what if you had crosstalk as a parameter and you passed it as a bulldog?
If you had cross dog as a parameter and you cast it as a bulldog, it would still, so okay, if cross dog is calling it, right, and you had passed in cross dog, the compiler only sees the static types, right? So the compiler looks for this method, it finds it, it's done. If you change it to bulldog, right, so you change cross dog static type temporarily to be bulldog, then it's exactly this scenario. So it still doesn't matter. Okay, question. What if there's an argument with bulldog in the dog class, but no same argument in the bulldog class, right? Okay, cool. Then it would run the one. Then it would run the one in the dog class. Mm-hmm. Yes. Then it goes back up, goes back to the superclass, and it runs the superclass's method that it had selected. So this no matter what, I need you to sort of like remember this. No matter what, the compiler will select the type for you. If it doesn't find the same exact function signature in the dynamic class of the caller instance, in this case crossdog, it'll go back up to the superclass and run that one. Okay? So I have two more points here that I want to make. And I'm also going to have to move on in the interest of time, but I will take questions after. So stay around. So I'm putting this up here. We don't care about the dynamic type of the arguments. One. Second point, dynamic method selection only helps with overridden methods, not with overloaded. As you can see, right? We tried to use dynamic method selection with overloaded. We passed in something that was actually a bulldog. It didn't do jack shit. All it does is the compiler will select something that looks like this, and then we will look for an overridden method of that type. We don't care about overloaded methods for dynamic method selection. Does that make sense? From the example, as you can see, this is in red, this is in blue. This mattered for us. The fact that there was a separate method that took a bulldog, the fact that the bulldog's bark method was actually overloaded, didn't matter to us. So overloading does not matter for dynamic method selection. Only overriding matters. Cool? Okay, so more questions on this part I'm going to take later because we have some more things to get through. I'm going to move on in the interest of time, all right? Is that cool? Sorry about that. Hopefully this is helpful. Okay. Weird things and what ifs. What if you have ambiguities? So there are some things, what if this happens, right? Let's see. Okay. So what if you have something like this? In the bulldog class, which extends dog, you have a bark method that takes in a dog and a bulldog. So in that order, remember, order matters, right? It takes in a dog and then a bulldog. And then you have another bark method that takes in a bulldog and a dog. Okay? Cool? What happens if you try to call real bulldog.bark real bulldog, real bulldog? Which one does it call? So I heard the second one. Why do you think so? Whoever said it.
So the second one is real bulldog. Static type is bulldog.
Okay.
Just like that one, and then real bulldogs. It's still like real bulldog, but that's like a subclass of dog.
Sure. But the first one, okay, so if it's the first one, this real bulldog can indeed fit in this dog, right? And this real bulldog can fit in this bulldog. Similarly, this bulldog can take this, and this dog can take this. There's an ambiguity here. This is ambiguous. Both of these work, and neither is better than the other. Because in both cases, you are like, okay, if you had something like bulldog, bulldog, right? If you had the third method here, that was of type bulldog, bulldog, there's no ambiguity. That is the best one. Because in that, both of these arguments are actually bulldogs. So that's the one you should be taking. It's the most specific. This is going back to the most specific, right? But in this case, both of these have one type that is specific and one type that's not. So this will actually be a compiler error. Let me say that. And this will be, yeah, so running this line will be a compiler error. The compiler will realize that it is unable to decide which one to run. And it will say this is ambiguous. It'll be a compiler error. Okay? If you have more what ifs about this, so I'm gonna go over this quickly because these are just like random things to think about, like what would happen in this case and what would happen in this case. I really encourage you to try it out. Just write some code, it's like 10 lines, and there's an online Java compiler if you don't want to like create 6 files to do this. Just type it out and try it. Okay, it'll be fun. So the compiler sees two methods, both of which work equally well, compiler error. Okay? Okay, yes, question. Dog, dog, and dog, bulldog?
Yeah, it would choose the
It would choose the second one because it's better, right? Okay, so I mean, this is my guess. I'm not 100% sure about this, so you should try it out. I still encourage you to try it out. These things, it's really like finicky. Like maybe this happens, maybe that happens. It's sort of, that's my best guess is it should do that. But if it doesn't, then there may be reasons for that. I'm not sure. Try it out. I really encourage you to try it out. Yes. Yes, they get bound at the same time. There is no order. Okay. Okay, and then I have this up here. I knew this would happen, that if I bring something like this up, there would be like a 300 what ifs. So I encourage you to try it out because really it's not useful for us to discuss all of them right now because I'm not sure. It depends, and you should really try it out. It'll be fun. Okay, cool. Static methods. So I promised somebody we get to static methods. Here we are. Static methods are not overridden. You simply cannot override static methods. This is great. Why is it great? Earlier I told you that dynamic method selection works only with overridden methods. If static methods are never overridden, this can never be a problem for us when doing dynamic method selection things. Awesome. Let's see what happens. Let's say you have two methods, public class dog, public static void bark, public class bulldog extends dog, public static void bark. Okay? So two classes. Now you might think, hey, this is overriding. They have the exact same type, public static void bark and public static void bark. Here's the thing though. In Java, this is not actually overriding. Now this is weird. Don't dive into this black hole of madness. But this is not actually overriding. This is something that's called shadowing. I don't think you have to know this for your midterm. I mean, for static methods, yes, but there's a whole thing of shadowing that's much bigger than just this. So for now, just trust me when I tell you this is not actually overriding. All that's happening is if you are looking in the bulldog class, this is the one you see. If you are looking in the dog class, this is the one you see. There is no ambiguity here. Okay, there is no dynamic method selection because this is not actually overriding. Dynamic method selection happens only for overriding, and this is not overriding. Question? Exactly. So it's really simple. You will just run whatever the static type is. That's it. Okay, so let's say you have 5 of these. Real dog.bark, dog.bark. Okay, notice how static methods can be called with the class's name. Okay, so you have real dog.bark, dog.bark, real bulldog.bark, bulldog.bark, cross dog.bark. What's it gonna print? First one, what is the static type? Real dog. Remember what the static type is of real dog? Dog. What's gonna print? I'm a dog. The next one, dog.bark. What is gonna print? Scream it out. I'm a dog. Real bulldog.bark. I'm a bulldog. Bulldog.bark. Cross dog.bark. I am a dog. It only looks at the static type. That's it. No dynamic method selection. None of it. Cool? All right. This one is easy. Okay. Moving on then. Static methods are not overridden. Decide what to run during compile time and then just run that method. Don't even look in the dynamic class. Super easy. Much easier than what we did before. Okay. Cool. Step 10. Factory methods. Now you guys are like, what the heck are factory methods? Why am I talking about this? Don't worry, just Factory methods are methods that create an object and they return it. So their return type is a new object that they create. It's a factory. It essentially creates objects and returns them to you. Okay? So something like this. Public dog make new dog. If this method was inside like the dog class, it returns to you a new dog. It returns to you a new object. We call it a factory method. It's just like a type of method. Okay? You don't have to use the word factory anywhere or anything like that. It's just called factory method. Cool? So I have some code here. Sorry, it's small, but let's see what we can do. So I have public class dog. It has a method public void bark. It has a method public dog make new dog. It has a method public bulldog make new bulldog. Okay, so the dog can make a new dog and a new bulldog, and this returns a new dog and a new bulldog. The bulldog can just bark and crawl. Basic. Cool. All right. So there are two use cases for factory methods, and I'm going to show you both. Use case 1 is something like this. Dog D is equal to real dog dot make new bulldog. So what I want to ask you is what keeps happening to this? Hold on. What is the static type of D, of this variable D, and what is the dynamic type of this variable D? I don't want to do that. Okay. Jeez. Okay, static type dog and dynamic type I heard different answers. So somebody said bulldog, okay, and anything else? Okay. So that's right. So far so good. This one is supposed to be fine, right? D has static type dog from that red text and dynamic type bulldog from that blue text. There's a second use case which is a little weirder. Real dog dot make new dog, whole thing in brackets dot crawl. Okay, so I'm not assigning the result of real dog dot make new dog to any variable. Okay, I just use it directly. Can everyone read that in the back? Do you need me to zoom in? Okay, let me see what I can do. It keeps like switching, so let me see what I can do. Okay, let's hope it says. Okay, so real dog dot make new dog dot crawl. I'm not assigning the result to any variable. What is the essentially what is the static type of that expression, right? The thing you see in red because it thinks I've made spelling mistakes, right? That entire chunk. What is its static type? What do you think? I hear dog. Why do you guys think it's dog? Somebody, just be brave. So I'm making a new dog. Okay, so let's see. Let me just show it to you guys. I actually think this should have been make new bulldog. Haha, my bad. That's the solution. Well, let me just show you why and what's going on. So the static type of this, I changed it to make new bulldog. Sorry, I wrote these slides yesterday and I made some typos. So the underlined object, it doesn't have a variable to reference it by. First of all, let's get that clear. There is no variable. If I want to reuse this object, I can't. It's created for this line. After that, it's immediately destroyed. Okay? It will have a static type of bulldog, and that's in green. And the reason its static type is bulldog, there's a very special reason. The reason is because now we got to look at the return type of this method. That's why it's bulldog. It's not just because, it returned a bulldog. It's because its return type was bulldog. Okay? And the reason its dynamic type is bulldog is still because of the same reason. So a question for you is, if I change this to public dog make new bulldog return new bulldog, that's still okay, because if I say the return type is dog and I actually return a bulldog, that's fine. It's not a lie, right? But it's this guy's static type will be dog in that case. So the static type depends on the return type of the function making this. Does that make sense? Is that clear? Questions? Yes.
So for line two, like instead of having like dog linked to dog, new to dog, return new dog, you what if you have say a dog linked to dog, return you bulldog?
That's okay.
Then then it would be like dog.
Yes, the static type would be the return type of that method. The dynamic type would always be the thing after the keyword new. Okay, so I show that as a summary, I think, in the next thing here. Here's a summary. Dynamic type is the class after the new keyword. There's no problem there. There should never be a problem there. Okay? Simply the thing after the new keyword. That's the dynamic type. The static type either is the static type of the variable you're assigning it to, which was case 1 that we saw. If you're not assigning it to any variable, then it is the return type of the factory method. Questions about this? Okay. Cool. Casting again. This one's really simple. So should be really short. Also, how am I doing on time? It's 12. Okay. So I have to, can I take 10 to 15 minutes of your time? Okay, cool. All right. So let's do casting again. This time it should be much simpler than what you've seen before. So it's a simple use case. So far, understand that we've only tried to make objects more specific by casting, right? We did something like bulldog crossdog.crawl. What if I do dog real bulldog.crawl? You see what's going on? First time, like all the examples I've shown you so far have been take this object and make it more specific. What if I try to make it less specific? As in I try to cast it to its superclass. So I take the real bulldog and I say, hey, trust me, it's actually a dog. First of all, it's going to compile. So let's see. Let me ask you this question. Is this line, the second line here of code, is it going to compile? I hear some yeses, I hear some no's. So let's do the same thing again. Someone from the yes crowd, be brave and tell me why. And someone from the no crowd, be brave. All right, who's going to do it? Okay, yes?
So it's going to compile because real bulldog is a subclass. So it is
Okay, so it's going to compile because real bulldog is indeed a subclass of dog, and it's going to compile. All right, someone from the no crowd, you go.
Then it checks now it's comments that the bulldog is a dog. Now it checks to see if the dog class has a method called dog.
All right, so you're both right. That is absolutely correct. Here's what's happening, right? This part of the statement is fine, right? Of course, real bulldog can be casted to a dog because it is a dog, right? That's fine. This half of the statement is not a problem. It's the fact that after that, I do dot crawl. Now the compiler is going to look in the dog class for a crawl method. If you remember the YouTube video I watched where a bulldog was crawling, right? Only bulldogs can crawl. Normal dogs don't know how to crawl. So what I've done here is I took a perfectly well working line, real bulldog.crawl, and I ruined it. It no longer compiles. Okay? Makes sense? Both the answers are correct here. This part is fine. Dog, real bulldog, the casting is just fine. It's the fact that after that, I'm going to start looking in the dog class for this crawl method. Make sense? Awesome. Cool. Yep, so the underlying part can never be an issue by itself. If you cast something to its superclass, that itself is never an issue. That's fine. It's the stuff you do with that. It's the next part. Now the compiler looks in the dog class for the crawl method and fails. What about dog real bulldog.bark? So not only does this compile, it is the behavior for this during runtime is as if you didn't have that cast at all. If there was dynamic method selection to happen, if there was a bark method that was overridden in the bulldog class, that is the method that will still run. Because sure, the compiler just looks in the dog class for a bark method, it finds it, it says this is the one that I'm going to run. During runtime, you're casting whatever you did, nothing matters. All your casts don't matter during runtime. Runtime just says, did you lie to me? Nope. Okay, all right. I'm just going to look at the dynamic type. The dynamic type of real bulldog is still bulldog, so it looks in the bulldog for that exact same method, which is void bark. Okay? Questions? Cool. Yes. This would print, looking here, this would print I'm Bulldog because of dynamic method selection. Questions? Okay. That's it. That's everything from static class and dynamic class. Okay, so I think let's take a break. Let's take 5 minutes. It's been a long journey. All right.
One of the slides was I didn't finish writing what was
Absolutely. Sorry
like
about that.
one before cast.
Okay, so it would have run the one with bulldog B. That's because when you cast crossdog to your bulldog, it looks in the bulldog class for the best method that you can find. It finds the one in the bulldog class. It selects that and will immediately run, and then runs up.
Okay. There has
To look in this class, the static class, you relabeled the box. You said, look in this class inside. It looks there. It finds something that works for you.
so even if the static kind of one is dog, it'll think it's static. And is that with the overloads? Okay. So say that the whole class dog has both bark with dog and walk with bulldog, and it's just a small dog, right? Or what's the difference? What is that still example? Is that on the two functions on the parameters, and so it just but so with all supposed to go up to dog class and check which arguments were specifically, but so if bulldog is a dog, but then there's bulldog and dog. It's not that
Oh, here. This one.
Wait, let me look at the So, yeah, that's because midway through I changed this to dog. This one is not supposed to be good. I'm sorry. I changed that midway and I had a typo. I'll fix all of these.
This is kind of confusing. You said like it doesn't matter which class it is. Because you were saying something about like earlier on something about like we cast it as like a different.
Yes. Okay, so let me what happened here is now you are telling the compiler to look in the dog class for a bar method. Right. The compiler will look at the dog class and find the bar method. It will select that and the signature that it runs.
Which is the one with dog.
They are both without any arguments right now. And the dog class has the bar method, and the bulldog class has the bar method. So both don't take any arguments. So now it selects the one in the dog class. Now what's going to happen when you run that? All this casting
Oh, it doesn't matter.
It doesn't matter because the first real bulldog is a bulldog. So we will look for this exact same signature in the bulldog class and we'll find it. And that's the one we run. That would have been the exact same thing that would have happened if this dog wasn't that dog. That was even under my son. That was another thing.
And then what if there was something there? Then it would change.
It depends. Yeah.
Like just
Yeah.
like
It depends on the
then it might change. Another question is like it's like static. Because you did
Okay, so he went through the lecture and yes. He didn't. So I don't know. But I haven't watched all the lectures. Of course, I went through your slides. I couldn't see anything significant. So I not said anything about that. I tried to do that. But no, she also not done the time. We won't be doing time.
Okay.
That's it takes a lot of time to use
Right. So for these two methods to be considered the same, does the parameter range have to be the same?
primary thing can be whatever the
didn't have a method that took in a bulldog, would that be an error? I forget.
So this is real dog. Takes in real dog. So if the dog class has a method that can take a dog, that's fine.
Because a bulldog is a dog.
Is a dog.
So it would just return the I am a dog.
Whatever. Yes, this would return the animal. This one will be.
So say, going back to my question I had, say if you have like attribute or bulldog, it spots equals falls into the dog can have that attribute, and you add your dog into a bulldog, or bulldog into a dog, whatever. That would error during the compound time, but it wouldn't during the running time, correct? If you were to like,
Field are still like essentially if you don't hide that it's going to read or that it will be looked up here and try it out. Try it out.
I put the visualize.
Yeah, don't take my word for it. Exactly, try it out.
So what I found has this dog and dog bark.
Okay, so the class is the dog, and then you do the bark. Okay, here's what happens. And this is the exact dump that I have somewhere down, so you want to go and open up. Okay. Here, instead of if this was bark, I think I have it here. This one. This is the one. So, see, it would actually still dog and even some hits. First, if you check the dog class, you see that it's not bark. There it is. Right? Because you wrote it, that it's the dog. Trust me. So check the dog class. It's fine. The method compiles. It selects this method to be the one to be the type of the method that you have. Right? Then real bulldog, it looks at the dynamic type, which is actually bulldog, goes here, and it finds the exact same method. So that's what we're done.
I mean, what if this method be static?
Okay, so static methods are different. If you have a static method here, both of them are static?
Yeah.
If both of them are static, then it just looks at the static class. Yes, then it would run the dog. Then it would run this one. If they are static, it just looks at the static type of this type. Static type of this type is the dog.
Rename the bulldog.
Rename the dog, yes. So it would be this one.
So you're talking in these platforms like no matter what argument you put, you only document the time.
Does not care about the dog. Okay, Karuna, I'm going to take maybe 10 minutes to do my query for captain and if it shouldn't take too long, so it's really short. 10 maybe for 30. No, Gotcha.
All right, let's come back. How's it going? How are we doing so far? Okay, how do we feel about static and dynamic type now? I want to see thumbs up. Feel good? All right, cool. Okay, how do you actually feel though? Don't worry about my feelings now. Still feel bad? Okay, sort of. Somewhere, almost there. Okay, cool. Nice. All right, sounds good. Now I'm gonna go over abstract. Also, so I'm gonna all the typos I had that I've been fixing on the go. I'll fix them all and post these slides again and write typos have been fixed, so you all can refer to them properly. There are some typos, so if your friends see these and they're like, "What the heck?" Tell them there's some typos. I'll fix it. Oh, they do, but I changed them only on one slide. I duplicated the slides, right? Okay. So now we're gonna talk about abstract classes and interfaces. This is gonna be a much shorter and simpler discussion. After which, in about 10 to 12 minutes, I'll give it over to Karuna so you can stop hearing my voice, and I'll just sit down. All right, abstract classes and interfaces. What is an abstract method? Simple, it's a method without a body. So you see this method here? It's written abstract void vapor method string name. There's no body. I just wrote this one line. This is an abstract method. If I define a method and I don't give it a body, it's an abstract method. All right? Okay. Note, have to write the keyword abstract if you don't want to give it a body. You got to do this. Okay? We'll see an exception to this in one sec, but you got to do this for now. Yes? It's a great question. Why would you want to make an abstract method? Philosophy. So, an abstract method, for instance, is useful in I'm thinking of an example for you. Let's say a shape. Let's say you have a class called shape. And there's a method in it called get number of sides. How many sides does a shape have? Who knows here? I don't know. How many sides does a square have though? 4. Triangle has 3, right? So something like get sides method in the shape class, every shape should know how many sides it has, but the shape class itself doesn't have any sides, or it doesn't know anything about that. Does that make sense? That's an example. It's an abstract method. It's like this method should exist in classes that extend me, but I myself don't know how many sides I have. Does that make sense? That's like one reason. And there are multiple reasons why you would want to have this in real life. Like if you have a list, for instance. Now, it's not a linked list, not an array list, not any specific list, just list. And you say, of course, every list should be able to add elements to itself. But how am I supposed to add to it if I don't even know what kind of a list I am? If I'm an array list, I'm supposed to create some array and add at the end. If I'm in linked list, then I'm supposed to make a node and add somewhere, right? So every list should be able to know, or well, every list has to be able to add, but the list class itself or the list interface itself does not know how to add. Does that make sense? That's kind of the philosophy here. That there are some methods that should exist, but the class itself doesn't know how to define them. Cool? Okay, philosophy. All right. What is a concrete method? It's a body. It's a method with a body. So these are the methods that we've been dealing with all our lives, or at least through 61B and 61A. Void vapor method, string name, and then do some stuff. That's a concrete method. So I've defined an abstract method, I've defined a concrete method. What the heck is an abstract class then? If a class has any abstract methods, then it must be declared abstract. Simple. Abstract class vapor class, abstract void vapor method string name. If a class has any abstract methods, it has to be declared abstract. The class itself is abstract. So the shape class in my example would be an abstract class. Yes. Great question. An abstract class can contain other concrete methods and ordinary variable declarations. So thank you for that question. Helps me get to the next slide. All right. So example, abstract class vapor class, public int x equal to 30, abstract void vapor method string name, and then public void add int a return x plus a. This is fine. Cool. All right. Simple enough. An abstract class cannot be instantiated. So if you have a vapor class, something like this, then you do vapor class x equal to new vapor class bracket bracket, not allowed. This is not okay. And the philosophy of why this is not okay is because what if I try to do something like x.vapor method and I passed in some name? I don't know how to do that. No one defined it for me, right? So that's why you just can't create an x with dynamic type of vapor class. But the static type can be vapor class. So abstract classes can be the static type, just not the dynamic type. Cool? Yes. This will be a compiler error. Okay. Vapor class x equal to new dog is allowed if dog extends vapor class. Okay? Cool. So, what is an abstract class? A class that extends, okay, sorry, not what is an abstract class. Here's a new fact. A class that extends an abstract class, it has to do one of two things. Okay, so for instance, in my previous example, I had a dog class that extended the abstract class. It has to do one of two things. One, it must make all the methods that it inherited concrete, which means it must provide bodies to all the methods that it inherited. Okay? The other thing it can do is, sure, if you don't provide like concreteness to all of the methods, you yourself must be abstract. Questions about this? Okay. Cool. So either provide implementations or yourself be abstract. Otherwise the compiler will complain. Yes. It inherits the name. That's all it inherits. Okay? Yes, question.
Why would you make an abstract class that extends another? Is that what you're saying? That extends another?
Yes. So coming up with examples is hard, but let's see if I can. Let's say you have a list, then you have array-based lists, right? So now a list itself has to be able to do only, let's say, add and remove. An array-based list better also be able to destroy the array, maybe, right? But itself, like, maybe then there's array-based lists has some more specific types. Okay, like maybe that's possible. Okay, let me see if I can do something better. Let's see mammals, right? It's probably an abstract class. Like mammals, lots of things. Mammals should be able to walk, but how do they walk depends, right? Below mammals is animals. Now animals specifically should also probably be able to scream, but how they scream is still we don't know. Make sense? And then below animals, dog. Now this is a real thing. So this should define everything. Make sense? It's all, it really like these kind of questions, they are present in modern day code, and so it's a thing that's possible. When the use cases, you can really make up whatever you want. Like, it's just this is allowed. Yes. So I'm saying that if the subclass does not give definitions to all of the methods, then it has to be an abstract class also, because there are still some methods that haven't been defined. Yes. Yes, an abstract class can extend another abstract class.
So if there's a subclass that's a subclass of, so if there's a class that's a subclass of an abstract class which extends another abstract class, does the ultimate like subclass have to like
Define all the methods? Yes.
like all the
Yes. Yes. So if there's an abstract class that okay, so if there's an abstract class that extends another abstract class, and then there's a subclass that extends this abstract class, this subclass has to provide concreteness to all the methods, to everything. Cool? All right. What is an interface? It's similar to an abstract class. Let's start with that. Except blah 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 blah. So there are 6 differences. Okay? So it's similar. Everything is the same except for these 6 things. Okay? Get ready. 1. Like I said, abstract classes can have whatever variables. An interface can only have variables that are public, static, final. What does final mean? Final means a variable's value cannot be changed. So if you implement that interface, you can't change that variable's value. Okay? So this can be used to define things like the universal gravitational constant. No one should change that. Like, hopefully. Okay? Cool. That's one difference. Second difference, the only kinds of methods it is allowed to have are public. So an abstract class can have whatever methods, but an interface must have public methods. Cool. All right. They can be static too. Like public static is fine too, but they have to be public. They can't be private or protected or anything else. Cool. All right. Next difference. We don't need to use the keyword abstract. So you see how I told you earlier that if you had abstract methods, you had to write the keyword abstract? For interfaces, you don't need to. For interfaces, if you just write the method itself, like the name, without the keyword abstract, it's automatically abstract. Okay? Anyone have a question? Cool. In fact, oh, sorry, hold on. Okay. We don't extend an interface, we implement it. So this is the keyword we use. For abstract classes, we say square extends shape. But for interfaces, we say implements. Also, the example of list that I've been giving all this while, I think list is an interface, not an abstract class. So I've just been using them interchangeably. But list, I think, is an interface. Don't quote me, but I think so. Okay? Cool. Next, if you want to provide definition, if you do a function, if you want to provide a concrete function, then you actually have to use the keyword default. This is the opposite of an abstract class in this sense. Abstract classes for concrete methods didn't have to use any keywords, and for non-concrete method had to use the keyword abstract. Interfaces for abstract methods don't use any keyword, and for concrete methods use the keyword default. Cool? Okay? Finally, a class can implement many interfaces. So a class can only extend one abstract class, but it can implement many interfaces. For instance, ArrayList implements comparable, iterable, blah, 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 where comparable is an interface, iterable is an interface, and so on. The difference in usage, usually something that is an able, so comparable, iterable, these are usually interfaces. But list is also an interface, so this is not the strict rule here, usually. And usually the things that are nouns are abstract classes, but again, list is also a noun, but it's an interface. So there's a rule of thumb is if you see an able, it's usually an interface. Because interfaces provide like this ability in some sense. A class that is iterable should have two methods, next and has next. This is one thing, for instance. Yes. Mm-hmm.
Does that mean like only classes within the same package can implement an interface if like any functions that don't have a body are defined by default?
I didn't quite catch that. So why would that mean that only the classes within the package can implement this interface?
I thought like default meant that like only classes or only classes or interfaces within the same package could ever like use those methods.
Not that I'm aware of. What default just means that this method will have a body as far as interfaces are concerned. That's what I know. I think Karuna is looking it up, so when I give it to her, maybe she'll reply to you. How's that sound? Cool. Okay. Awesome. Summary. Big chart. Interfaces can implement as many as you'd like. Abstract classes can extend only one. Interfaces can only declare public, static, final variables. Abstract classes, any variables. Interfaces can only declare public methods. Abstract classes can declare any methods, except for private. Should have said this earlier. So just not private methods, but whatever you want apart from that. Yes.
So if you have two interfaces and they both have methods, like empty methods with the same exact signature,
Sure.
and you have some class that extends both of those interfaces,
Implements both of those. Yes.
would that like have a compile time error or something?
So here's the fun fact, right? If you have two interfaces with two methods, neither of which have a body, right? And you are implementing both of them, why would it be an error? Well, both of them didn't have a body and now you're giving it a body. It's the same name, right? So again, as far as I'm aware, there should not be an error, but try it out. I don't see why it would be an error. So if I was to guess, it's not an error. Try it out though. I don't want to make a claim without actually trying it out myself. Okay? And interfaces can be so interfaces and abstract classes can both be the static type of variable. You can put them on the left hand side. Interfaces can have unimplemented methods. Abstract classes can also have unimplemented methods, but you must use the abstract keyword. Interfaces can have implemented methods or concrete methods, but you must use the default keyword. Abstract classes can have implemented methods. And interfaces unimplemented methods must be defined in implementer. Abstract classes unimplemented methods must be defined in the subclass. All right, questions? Yes. Why would you use one or the other? It's a great question. It goes back to when Java started. All right. When Java started, interfaces and abstract classes were very different from each other. Now they're not. So now, whoa, this thing. Okay. So now there's actually very little, like you can usually use one or the other. But historically, this has not been the case. So until Java 8, which is I think like 4 or 5 years ago, interfaces couldn't actually use the default keyword and define a method. So that was one difference, for instance. But as we move on with Java, interfaces and abstract classes become more and more similar to each other. And so I don't have an answer for why you would use one or the other. It's sort of, we are converging towards both of them being the same. When I say we, not me, the Java people, but yeah. All right, what else? Yes.
Can you just go back a slide for 1 second?
Sure thing. Oh yeah, sorry. I will also put these up so you guys can take notes. I know I had a lot of text on them. All right, more questions? Okay, with that, I give it to Karuna. Woo.
How does this work?
Just,
Hello?
Just hold it.
Okay.
So I know you guys really want to do some midterm questions. So we have a midterm question on interfaces. So if you guys have like a piece of paper or something, recommend you take it out just to write your answers and work through the problem. So for this problem, we have the following generic higher order function interface, unary function. So it has a method apply. So a SPI is a unary function that wraps around another unary function f. For any input x, it returns the result f would return, but it remembers the arguments on which it has been called and can print them out on command. For example, if square function represents a function that squares integers, then we can create a variable sq that's a unary function and assign it to new square function. So then if we print out the result of applying the method apply with the argument 4, then it would print 16. And then we can create a SPI variable, which is of type SPI, and we pass in SQ into its constructor. And then if we call apply on it with 5, it'll print 25. If we call apply on it with 2, it'll print 4. And if we call apply on it with 3, it would print 9. So far it's been doing the same thing that SQ's done. And then we can also print argument history, and it would print 5, 2, and 3. And it's non-destructive, so if you would print it again, it would still print 5, 2, 3. So why don't you guys take some time to figure out how to fill in the SPI class. So I'll give you guys like 5 minutes to do it. Feel free to talk to each other. Oh yeah, if you want to see the slides, they're on the piazzas for CSM and regular 61B. How many of you guys want more time? Okay, a few of you. Maybe we'll do like 2 more minutes. Okay, so let's go through this together. How many of you guys think you know how to do this problem? Okay. Okay, so I guess let's start off with, if I was solving this problem on a test, I'd first, look through the skeleton they gave us. So we can see that we have some fields, some place for fields. We have a constructor, we have the apply function, and the print argument history function to fill out. So starting off, let's try to get some low-hanging fruit. So we know what, for the first line, public class spy, what do you guys think should go there? They told us something about spy, which would help us out. Yeah. Yeah, so it implements the unary function because it's implementing the interface. So does that make sense, everyone? Yeah. So is there any other low-hanging fruit you guys see here that we could easily fill in right away? Yeah. Yeah, exactly, because we know that if you see on the example on the left-hand side, when we created a new spy, we passed in the variable sq. So we know that the constructor takes in a unary function, which is what sq was. So given we know this, now we can try to examine the apply function and the print argument history function. So how does the apply function work? How is it different from the unary function that's passed in? How is it different from like the unary function's apply function? Is there a difference? Sorry? Yeah, it remembers the arguments. But in terms of what the apply function returns, do they return the same thing or do they return different things? How are they different? Are they different? No, so they return the same thing. So we know that apply can run basically the same way as function, so we can just call functions apply. But then we have to save the argument history. So we'll have to save it into some sort of data structure. So what data structure should we use? Yeah. Yeah, because both of those implement the interface dequeue, which helps us we can add last, for example, that's what we do. We add last every time we call the apply function. We'd add the argument, and then if we call print argument history, we can just call print dequeue. So does the general idea of how we're going to solve these two or fill in these two methods make sense? Yeah? No? Okay, so do you guys have questions right now? What did it make sense so far? Yeah. Oh, okay. So here we're trying to implement like a generic class. So the reason we're using the angle brackets is because SPY can be applied to, integers or maybe strings or something else. And we can see that like our unary function also has angle brackets, the interface. So we're just trying to make it generic, which is when we use it. Any other questions? Okay, so then now we know how we're generally going to fill in these functions. What fields do we need to have? So like the first two rectangular blocks, like what would we need to save? Yeah. Yeah, so we need to save a unary function itself. So when we call apply, we can apply it. And, oh, what else should we save? Yeah. Yeah, so you can use, an array deck or a linked list deck, and we're going to use an array deck, and we're going to save the unary function. So then what should we do in the constructor? There are two things we need to do in the constructor. Yeah. Yeah, so we're going to set this dot history to a new array deck, and we're going to set this dot function to the function that we take in. And then does anyone want to help with apply? So what would we take in as a parameter for apply? Yeah. Yeah, so since we're using t as like the generic value here, so we can just do, it's of type t, and then call it whatever you want. So we can call it like type t x. And then what do we have to do inside the apply function? What's the first thing we should do? Yeah, so we can use the function on the parameter, but then we would have to save that in a variable. So instead, you could also first add it to the history and then return the value of applying that function, and then, yeah. But you could do the other way too. It would just take one extra line. And then finally, for print argument history, what do we need to do? Yeah.
Call print DQ on this dot history.
Yeah. You actually don't need to include the this dot. You can just call history.printq, DQ, and that's it. So we're done. Do you guys have any questions on this problem? Yeah. Oh, so we can see what it does from looking at the interface box that's given here. So we see it adds first, adds last. We can check whether it's empty. We can print it. We can get the specific index. So it's basically like a data structure. Yeah. Yeah. Mm-hmm. Actually, so in the constructor, we also don't need the this. But for if you see this dot function equals function, we definitely need a this there because the variable names are the same as what we take into the parameter of the constructor. So yeah, you can use it for clarity or you can forget it. But if you have another variable, such as we do in the constructor with the same name, then you would need to include this. Okay. If there are no other questions, then, oh yeah. Oh no, so they gave that to us. So they're telling us that it's this array deck and linked list deck inherit from that interface, but we don't need to ourselves implement those data structures. Does that make sense? Yeah. Okay. Yeah.
So is the only time you use this is only when you have a parameter with the same name?
Yeah. You can use it all the time. So we could have written this .history.print to q, but you can also leave it unless you have like the same name.
So the use of this is mainly because to avoid confusion.
Yeah. Yeah. But like for this .function equals function, you have to use this. If you want function, does that make sense?
Because they have the same name.
Yeah, yeah. But otherwise it's
Otherwise, it's okay.
yeah, yeah. Yeah.
How do we know it's return function $5 rather than return function parentheses x?
Oh, because so if you did function parentheses x, then it would try. So when we do like a function parentheses x, it would that wouldn't even. What would that do? I was gonna say it's like a constructor, but it's not because we don't call new. So it doesn't work because function is like an actual function that it's an object that has a method apply. So you wouldn't be able to just put parentheses. Yeah. Okay. Yeah.
Why wouldn't you just create history on the very top line? Or why wouldn't you create the array history there? And why would you create it in the constructor?
I think it's fine if you created it there as well. Yeah. Okay. So now we can cover exceptions. So what's the point of exceptions? Exceptions disrupt the normal flow of a program's instructions so that we can detect and respond to errors. This is important because we want our systems to fail gracefully and to fail securely. So we don't want someone to be able to put bad input, for example, into our function and not be able to handle it. If that happens, we want to be able to throw an exception, which disrupts the normal flow of a program's instructions. So we have external errors, which is when the input is not in alignment with preconditions, so what we expect to be put into our function, or we have network failure, for example. There are also internal errors, which basically mean errors with your own code. So exceptions are objects themselves. They're descendants of the throwable class. As you can kind of see in like the tree over there, we have object at the top, and then throwable inherits from object. And then we see exception, error, runtime exception also inheriting. So we throw exceptions. It's a keyword you haven't seen before, specific for them. So for example, you can throw new exception. You can throw new exception with a optional description. So there are two different constructors here. You could also create a new exception object and then throw it afterwards. And then if you would call the method getMessage, the instance method getMessage on an exception, on an instance of an exception object, then it would return the description you put in if you use that constructor. So you may already be familiar with exceptions because Java throws some by itself. Do you guys know any of these? Have you guys seen any exceptions? I'm sure you guys have seen an exception. Does anyone remember any? Yeah. Yeah, null pointer exception. So there's index out of bounds exception. There's class cast exception, null pointer exception. So you may have seen these before. So when thrown, exceptions are propagated all the way up the call stack until the program exits with the exception, unless you catch the exception somewhere in the call stack. So in the diagram here, you can see that this top method is where the error occurred. So it throws an exception, and then it goes, if there's no way to catch it there, then it would go to the method that called that method and see if that one has an exception handler. And if that doesn't, it would go back to the next to the method that called that method all the way until you reach main, unless any of these has an exception handler that can handle the exception that was thrown. Yeah. Okay, so how do you catch an exception? You use what are known as try-catch blocks. So we don't always want to immediately exit when an exception is thrown. Sometimes sometimes you might be expecting some exceptions. You may have certain instructions for those exceptions that you are expecting, maybe. And maybe you want the program to continue regardless of an exception if you have like a default value or something, if the method you're trying to, call fails. So this is what a try catch block looks like. So inside try, we have some code that throws an exception. Inside catch, you can specify what type of exception it is. You state what you want the program to do now, and you can even throw another exception. And then you have another catch block where you have some other exception, and you can also, again, write what you want the program to do now, and you can also throw another exception. So something important to note is that each try catch block only catches one exception, not multiple. So what that means is, for example, let's say we caught some exception, so that would be the first catch block. If that throws another exception, the second catch block is not going to catch it. So you can only catch one exception from the try block. Something else important to note is that you can't catch a generic exception and then a more specific one. So by that I mean that when we're trying to catch an exception, it will go through the catch blocks in order until it finds one that fits the exception that we're dealing with. So for example, if in the try catch block, the first catch block was just exception E, so that means it would catch all exceptions, and the second catch block was null pointer exception E, that would become a compiler error. It wouldn't let you compile that code because exception would catch all null pointer exceptions before it could even reach the null pointer exception catch block. Does that make sense? Yeah. Are there any questions on that? Yeah. Yeah, that would compile. That would be fine because then that means that if it's not a null pointer exception, then it would be caught by the general exception one. But if it is a null pointer exception, it would be caught by the null pointer exception one. But it wouldn't be caught twice. It would be caught once. Okay. So then there's also like two classes of exception. There's unchecked exceptions and checked exceptions. So unchecked exceptions are errors or runtime exceptions, and they're subclasses. So errors are serious, unrecoverable errors, and runtime exceptions, common programming errors. And then checked exceptions are everything except for unchecked exceptions. So all exceptions except for error, runtime exceptions, and their subclasses. So checked exceptions are intended for exceptional circumstances, and unchecked for programmer errors, errors Java detects, and catastrophic failures, like running out of memory. So checked exceptions have this catch or specify requirement. So what this means is that you either need to catch the exception through like a try catch block, or you need to include the exception in the method declaration. So for example, if we have this method write list, it returns void, it's public, but we also need to include throws IO exception and index out of bounds exception if it has a possibility that it could throw either of those exceptions. So that's what we mean by the specify requirement. So why do we either need to catch or specify? It's so that other methods that depend on this method, that call this method, know what to expect and what to handle. For unchecked exceptions, there's no need to catch or specify them, but if you'd like, you can feel free to. So does the difference make sense between these two? Yeah? Okay. So if there are no questions, do you have a question? Yeah.
So if a method throws a certain exception, and then the method that's calling it doesn't have anything that will like handle that exception, it still compiles because it's possible that like other methods later might have that, or would it not compile?
So for example, if you have like a method, so you're saying you have a method that calls another method that might throw an error. But the method you're talking about doesn't have the catcher specify? No, it still has to have the catcher specify.
Oh, in order to even call that method?
Yeah. Okay. Yeah.
Do you mind explaining again, like, what's the point of adding like something throws
Oh, yeah. So It could be that your method is like a small method that helps like another method out, for example. And so if your method doesn't specify that it might throw this exception, then the other method that's calling it won't know that. And that would be a problem because it won't know that it's possible for it to throw an exception. So you just want to, you can either catch it, in which case you like, already catch the error, you're not throwing it, but otherwise you do need to include it.
So you would add like throws IO exceptions for every single like method of the chain.
Oh, so this is just when you like declare the method.
Oh, so like the problematic method would have this like throws some exception.
Yeah. Even if it doesn't, let's say it doesn't end up needing to throw an exception, but if it can throw an exception, you still need to have it.
And what about a class? What about like the method calling this method?
Yeah, so you would also need to handle it there.
So you have to keep writing throws.
Yeah. Okay. If no other questions, then we can try a midterm question. So this is from midterm 2 of spring of last year. So I'll give you guys like 5 minutes to read the code. Read the code and like figure out what it's going to output. Feel free to talk to each other.
Oh no, yeah, you're right. So after you throw the
Yeah.
mystery doesn't write throws exception because it has handler.
Sorry.
Like the method it doesn't require a throws exception because it has a handler like the try to throw zero. Wait, before it's zero. Yeah, it's for counter is. But the other one does counter is one. Yeah, this difference counter is one, and then so it's just zero six.
But you get the one.
Okay, do you guys need more time, or do you guys think who wants more time? Okay. Okay, so I don't think too many of you guys need more time. So let's go over it. So we're just gonna go over like the 2 lines in main step by step. So we start with calling mystery of 1. So when we call mystery of 1, we go into the mystery function, x is currently 1, and counter is 0. So we go into the try loop, or the try block, and we see while true, x equals x divided by 2. So what is x now? You guys can just shout it out. 0. So then we go into check if 0, with x is equal to 0. And we enter the if statement, and we throw new exception, x was 0. So we check to see if there's a try catch here, but there isn't. So then we're going to go up and we're going to throw this error. We're going to go back to the function that called it mystery, and we're going to see if there's a try catch handler there. And there is. So we will go into the catch block and return counter. So what was counter? 0. So then what do you guys think we're going to print? Well, mystery of 1 is 0, is what we print. Okay, and then we're going to go to the second call. So mystery of 6 is mystery of 6. So x is equal to 6. Counter is now 0. So we go into the try block. While true, x equals x over 2. So x is now 3. Then we go into check if 0 with x equal to 3, and it's not 0, so we just print out x. So what do we print? 3. And then we go back into our function. We increment the counter by 1, so counter is now 1. And then we print out counter is 1. And then we keep going in this loop because it's a while true. So now what is x equal to after we divide by 2? 1. So we check if 0, but it's not 0, so then we print out 1. And then we go back, we go again into the while true. So x equals x divided by 2, x is now 0. We check if 0 on x, so we go up here, we see x is 0, so we throw a new exception. And then same thing we did before, we come back here, we catch the exception, and we return counter. So, oh, sorry, did I not do this part? Oh, sorry, that was from last time. So counter is 2 when x was equal to 1. And then we go into the while true. So then we had calculated that we're going to return counter, which is 2. So mystery of 6 is 2. Yeah. So x with 0 actually never gets printed. So Java only prints exceptions automatically when they cause the program's execution to stop. So if we didn't catch the exception and it went all the way up and there was nothing that caught it, it would print what you see here, exception in thread main java.lang exception x was 0. So it describes the exception, but if you catch it and you don't like print it out, then it won't print out. If you had what?
Like if you had like the words throws exception on the method mystery,
Uh-huh.
would it still have like this?
So the execution would be exactly the same. Nothing would be different because you caught all exceptions. So yeah. Okay, does anyone else have questions on this? No? Okay. If not, we have another exceptions question. So this is from 2 years ago, their second midterm, question 3. So one common software engineering strategy is to create log files that can be manually examined if something goes wrong. In the code below, the write to log method writes the given argument to some log. What are the contents of the log file after the code below is executed? You may not need all the lines provided. So I'll give you guys like 3 minutes to work on this.
Oh, no, it said that this would happen. Like the, and the initial through it. Yeah. Normally you do this with field truck. Yeah, third one. Well, I also did everybody.
Okay, does anyone want more time? No? Okay. So let's see what this prints out. So we're gonna start with the first call. So print 10th on new int 0 to 10. So this has 11 elements. So we go into print 10th and we try write to log a of 10. So what's the 10th element in the array we passed in? 10. So we would write that to log. And then so the second call. So we do print 10th of new int 0, 1, 2, 3. We go into the try block, we try to write to log. But what's the 10th element of this array? Yeah, so there's a index out of bounds exception. So luckily we have a catch block, so we catch it. And what do we, so then we write to log, no 10th item available. And then we throw this exception. So then what happens now that we threw an exception? It stops. Okay, so then do we go to the next line, the next print 10? No. Yeah. Okay, great. So you print 10 and then you print no 10th item available. And that's all that you print into the log file. Any questions? No? Okay, great. So this is another question. So this is from a final. And it's an interesting question. So I'll give you guys like 5 minutes to read through this and figure out what the output will be. This is no. That's like one something that prints out. It prints out each character. RE or D.
Okay, let's do it again.
I don't know. Can you look it up? I can give you my like.
This is the final solution.
Yeah. Final question?
This is the solution, right? That's it.
No. These are different versions.
Yeah, these are different versions of the exam. So which version is this?
I know this is the model. I know that it's at least.
Yeah, it's just like that one. Yeah. Yeah. It's just morning.
Okay. I don't know why I got so. Do you guys want more time? No? Okay. So let's go through. Oh. Okay, so let's go through this. So we start, well, first of all, are there any guesses for what they think? Who thinks they got this? They figured this out? No? Okay. Okay. So we go into main and we see the first line is scarp G equals new scarp of ZEOIDEI dot to car array, and then R. So we create a new scarp object G with two parameters. So we set contents equals the ZEOIDEI, and then we set the magic character to the character R, and K equals 0. So then we go for each character C in G. So what happens when we do a for loop like this? I know you guys had a lab recently where you studied what happens. So does anyone? No? Yeah. Yeah, so it calls has next to see if there's another element, and then it calls next. So it calls this on the iterator. So in order for this for character C in G format to work, this colon format to work, the object you're calling it on needs to implement iterator. So iterator is an interface. So you guys did do this in your lab, right? Yesterday or this past week? So So in this case, we have this iterator, which returns this, and we have has next, which returns whether the k we're at is less than contents.length. So then we call, so first we call has next, and we see that there is a next, and then we call next. So what is k right now at the start? 0. So what's 0 mod 3? 0. So then we're going to go into this if statement, and we're going to set the contents of we're going to set the 0th element of contents to be equal to magic character, which is R. So now our contents is REOIDEI. Okay. So then what are we going to do? So then we would print out R. So yeah, we would print out R, and then we would also increment K. What will we do next? What does this loop do next? Yeah. Yeah, so it's going to call has next, and K is less than contents.length, so now we would call next. So now we have 1 as our K. So what is 1 mod 3? 1, so it's definitely not 0. So then we just go return car equals contents at K, and what would that be? E, because the first, so Z, or it used to be, 0. Now R is there, and now E is 1. So we would just print out, so we'd increment K, return that, so then we would print out E. So we do the same thing. We do has next, then we called next. So the next K is 2. 2 mod 3 is also not 0. So we're just going to increment K and return O. Then we call has next again. And now we're at, what is our K at now? 3, because we just printed out O. But this time, 3 mod 3 is equal to 0. So then we would set the contents of K to be equal to our magic character. So instead of I, it's now R. And then we increment K, so K is now 4. And then we return R. So then we print out R. So now we have R, E, O, R printed out. Then we do the same thing on the 0, 1, 2, 3, 4th. So K is now 4. We check has next, we go into next. We don't go into the if statement. We increment K, so it's 5, and we return D, and then we print out D. Now we do the same thing for E, and E, now we're at K equals 5, which is not, mod by 3 is not equal to 0. So then we just increment K to what is 6 now and print out E. And then the last thing we do is we do the same thing for I. So has next, then we go into next, but 6 mod 3 is equal to 0. So then we would change the I to an R and then return R and increment K. So now so far we've printed reorder. And yeah. Oh, so print line, it'll print, after you print what you wanted to print, it'll also have like a new line. Yeah. Oh, okay. So it prints each character, but it prints on the same line. So if I had done print line instead, then it would print R, then E, then O, then R, then D, then E, then R. Yeah. So it's just whether it prints on the same line or a new line. Yeah. So after this, we would check has next, but now 7, now K is 7, so then it would return that there's like no next. So it would return false. And we're done with this for loop. So does the for loop make sense so far? Yeah. And then we're going to print out a line. So that means we like move to the next line. So now we're going to go through each character C in G again. But the problem here is that we're going to check has next, but our K is already what? Yeah, it's equal to 7 because we never set K equal to 0 after the last loop. Does that make sense? So this is why there's nothing to print out here. So then I'll just print out a new line. So this is our output. Does that make sense? Yeah. Okay. Great. Yeah. Yeah. Oh, okay. So that's a good question. So his question was, how do we change it so that we would actually print out reorder again in the second loop? So does anyone have any ideas how we would do that? Where would you return that? Okay, so, well, the way you would do it here, so when we go into the second loop, what was the reason why we didn't return anything again? Why didn't we keep printing? Yeah, so basically when you have this 4 character C and G, what it does is it asks for an iterator. So it calls the iterator function, which returns this. So it returns the object itself. And then it calls has next. But has next returns false because k is greater than the length, right? So that means that at the end, once we've gone through everything, we want to make sure that k is not equal to, we want to reset k. Does it make sense that if we had resetted k, then we would have actually printed out reorder again? So where's a good place to reset k? Yeah. Yeah. Or no, yeah. You could reset k there. You could also reset k, for example, if you, yeah. Actually, that's where it should go. It should go before the return this.
And the second question is
Yeah.
so for iterative questions like this, so we always first call has next on G.
Yeah. So when you have, because we have this for loop, in this for loop's construction, like that's how this for loop works. It works by calling the iterator, and then it would call has next. So that's just this for loops. But if you outright were calling like dot next yourself, then you would have to call dot has next yourself too.
So it's like G dot iterator parentheses dot has next.
So when you call the iterator, it returns this. So then you just call has next on what the iterator return. Yeah, the iterator function return. Because the iterator function returns an iterator. Yeah. Okay. Any other questions on this question? No? Okay. Okay, so we have one final question. So this is from spring 2015, first midterm. So I'll give you guys some time to work through this. Yeah, so like 5 minutes.
Like for the question just now, right? Could you use like G dot iterator dot has next?
Yeah, you can.
You can't just, but in this case, it's the same as calling just G dot has next.
Yeah.
And then calling G dot next because it returns this.
Yeah.
But I remember in 61A, like you could return a new iterator, like a new object.
So in this case, they work the same. Like why wouldn't they work the same, I guess?
Oh no, yeah, they work the same if you do like return this, but if you were to change it to like return new iterator,
Yeah.
would that work? Because it will restart k and everything.
I guess the only question here is that it's within like its function itself.
Right.
So I'm not sure
If you can call
yeah,
itself,
yeah.
because it sounds a little weird.
Yeah, I'm not 100%. You can definitely like just try this. Like
Okay.
just run the code and
Okay.
try it. Yeah, I'll try it too.
No worries.
I'm not sure.
Got it. Thank you.
Okay, if you guys don't mind, we can go through this one together because there's not a lot of time left. So let's start. So we have inside the main method, we start with line 3, robocop rcop equals new robocop. Okay, and then we go to line 4, rcop dot report energy. So does everyone see why that's 0? Yeah. So which report energy method are we going into? Are we going into the robots or the robocops? The robocops. Okay. And then we call rcop.detain. So robocop or robot, or which detain do we go to? Well, yeah, that's the detain we go to because honestly there's only one. So then what do we print out for line 5? Halt citizen. Okay. And then we call line 6. So robot R equals, blank rcop. So what do we do inside this blank? Yeah, so what would we write in it? Do you need a cast for this? No, yeah, so you can just leave it blank. Okay, and then line 7 says r.report energy. So in this case, what would happen? Does anyone want to volunteer? Okay. Okay, so well, first, what does the compiler check for r.report energy? The static type. So the static type of R is robot. So it would see if there's a report energy function, and there is. But then during compile time, it would look for robocops. It would look for the function with the same method header in robocop. So it would print out energy, which is 0. And then line 8, we call r.detain. So what would this print out? Yeah.
It will be invalid because the robot class doesn't have a detain, which is a static.
Yeah. So the static type of R is robot, and there's no detain there. So even though the robocop actually does have a detain method, it doesn't. It's a compiler error. Okay. So then we move on to line 9, and this time, what do we put in the cast? What do we cast it to? Actually, in this case, we also leave it blank. So it's fine the way it is. Okay, so so far, do you guys have any questions? No? Yeah. So they said if a cast is not required, leave the cast blank. So yeah, you would leave it blank. Yeah. Okay, so for 10, then we go p.report energy. So what would we do now? Does anyone know what would happen now with this line? Yeah, compile time error. So this is also invalid. So this is because so P is of type police. So there's no such report energy method there. Okay, so 11 p.detain. Sorry. Yeah, halt citizen. Basically the same thing as before. So we see that police does have the method detain, so then we go into robocop's detain method. So for 12, we call r.enervate r, rcop.enervate r, and rcop.report energy. So does anyone have any guess of what would happen in this line? So what would happen when we call r.enervate r? Yeah. Okay. Yeah, by 20 actually. So R is of type static type robot. And when we call enervate, R is actually of dynamic type what? Robocop. So we would go into that method and then we would enervate R. So R's energy would go down by 20. And then rcop.enervate R, it actually goes to the same method. We also decrement by 20 again. And then when we call rcop.report energy, what do we print out? Yeah, negative 40. I feel like I heard a question. Yeah. Oh, because so when you call enervate, you're calling it on a robot R. and then you're decrementing that robot that you passed in's energy by 20, and it's a minus equals.
You're doing R's.
Yeah, yeah. Okay. So then we set r dot energy equal to 100 in line 13, and then in line 14 we call r dot enervate of r cop dot enervate of r cop, and r dot report energy. So in this case, what happens now? So what happens when we call r dot enervate r cop? So r static type is what? Robot. But the dynamic type is Robocop. So we go inside the enervate function here and we call it on rcop. So is it fine to put an rcop here even though rcop is a Robocop? Yeah, it's still fine. So we still call this method and we do r dot energy minus equals 20. So we reduce rcop's energy by 20. Then when we call rcop dot enervate rcop, we do the same thing. And we know that we started with r dot energy equals 100. So when we report energy, what should it be? 60. Okay. And then we call r dot report name. So r is of type, of static type robot. So we see there is a report name function. But then when we actually run it, it would look at its dynamic type, which is Robocop, and it would see report name, prints out class name. So what would it print in this case? Robocop. Yeah, you have a question?
Yeah, so in the energy one,
Yeah.
how come you put R in its argument, but it decrements it from sorry, you for like line 14,
Mm-hmm.
you put R cop,
Mm-hmm.
but it decrements R's also.
Okay. So is there like a whiteboard?
Oh, there is. So basically, you have R, and it's type robot, right? So R is pointing to an instance of Robocop. So whenever we make a change to RCOP, R is actually pointing to, or whenever we make a change to Robocop, it's actually pointing here. So either way, the changes are being made in this one instance.
Okay. So then line 16, we call rcop dot report name, and what would happen in this case? So it's also Robocop because we go into the same method as we did last time, because the static type of rcop is also Robocop. Okay, and then last line, 18. So now we say rcop.classname equals ketchup friend. So what would r.report name be this time? Ketchup fried. Or friend. Okay. Yeah, so that's all we have. Thank you guys so much for coming. We really hope it was useful for you.
Alright, we also take questions in the front because we have the rooms wherever they are. We're going to see it for a while.
R dot which one?
Line 12.
Yeah.
R dot enervate R.
I was charging my phone here.
R is static. R static type is robot. So it goes to robot class and checks whether it has an enervate method. It does have one, which takes in R, which is also a robot. But then during dynamic methods, checks whether R is.
So then during runtime, it would see
The first R, right? First R dot enervate.
yeah.
That R dynamic type is Robocop. Then it goes to the Robocop's enervate. And then although
I didn't prepare my questions on that.
it's R and Robocop thing, yeah, I'm kind of confused. Like line 14.
Okay, line 14. Okay, why don't you call one here? We can draw it out.
So line 14,
Right.
r dot enervate rcop. So well, let's write. What is the energy? Before we do line 14, what is energy?
Thank you very much for
Uh,
it makes so much sense now.
Line 14.
Yeah.
R dot enervate.
Thank you.
So before,
Okay, R is energy now. R is energy now. It's 100.
Yeah.
Then
Does it make sense that R is pointing to like a Robocop?
Yeah, because this line 6, right?
Right.
It's pointing to an object. Yeah.
Yeah. So this is like. Okay,
Oh, okay. So R cop is pointing to the same thing to R. Oh, okay. I see.
right, because we have robot R
Right.
equals
to
R
R
cop.
cop and R cop. Yeah.
Yeah.
And then when you call R dot enervate on R cop.
So now we call R dot enervate on R cop. So it goes. We know the dynamic type is Robocop, so it goes into
This one.
this function, right?
Right. Then subtracts 20.
Yeah. So it does R dot energy subtract 20, which is
So it
80.
becomes 80. And then it does R cop dot enervate R cop. And we know that R cop's thing is the same. So okay, got it.
Yeah.
Oh, okay.
Maybe I should have drawn on the board.
So that's all.
Yeah.
This helps. Thank you so much.
Yeah. No.
Can I ask a question?
Yeah.
So in here, there's a student asks you like, can I put this one in here? Right? But like, if I put in here, doesn't it? Because this one is the cast, this one is the contrastor. So if you put those things in here,
Oh.
then you cannot update it. If you create a new object, then you're using the same data.
So what you can do is you're not gonna put these. So you could just put new array deck in here.
I can do it like that.
Yeah. So let me also. Okay. So
I remember this bit of make this big guy.
which
Yeah, the other solution is they literally reduced it because they were like, okay, this is how many lines we gave you.
Okay, wait. Let me just draw it on the board. I think it's easier.
Okay, yeah. So there you go. Yeah.
You have. Okay, so you have like history.